moving on, we have the next method, which is known as elimination. Now, why do we need to use two methods? Because these two methods are tested, right? So sometimes the questions may say, use the substitution method to solve this pair of simultaneous equations. And then some of them may use elimination method to solve these simultaneous equations. So in other words, you need to be able to use both methods. Okay, so what is elimination about? Elimination is about adding or subtracting two equations with terms that can eliminate each other. Okay, what does that mean? If, let's say, I have this set of equations right here, what do you realize that is special about these two equations? It is that I have a 6y in the first equation and a 6y in the second equation. Now, this makes for a very good set of equations to use elimination rather than substitution, because you see there are coefficients, right? So for this one, let me label it the first and second equation. And if I were to add these two equations together, 1 plus 2, okay, what you will realize is the 6x does something special. So this is the left-hand side of the first equation added to the left-hand side of the second equation, okay, equals to the right-hand side of the first equation added to the right-hand side of the second equation, okay? And if I were to take everything out of their brackets and shift things around, if I have 7x here, you would realize that by adding the two equations up, I am able to now cancel off the 6y, right? Okay, and I'll get 10x equals to 10, which means x equals to 1. Now, that is the magic of elimination, okay? And so, if now I have x equal to 1, I can take my first equation and substitute that 3 times 1 plus 6y equals to 1. In other words, 6y equals to 1 minus 3, which equals to -2, right? And so y will equal to -2 divided by 6, which gives me -1/3. Okay, and so my answer would easily be x equals to 1 and y equals to -1/3. Okay, but what if I do not want to add the two equations together? Is there another way that I can eliminate the x or y terms? Okay, so let's look at the example 9, okay, in which I am trying to eliminate the 4x over here. Okay, but what you realize is if I were to add it together, it does nothing to eliminate the two equations, right? Okay, so let's try a different method. For 1 and 2, let's try subtracting the two equations, okay? So if I were to take equation 1 minus equation 2, right, what I will get is 4x minus 5y, and then minus the entire of 4x minus 9y, which will give me 3 minus 1, okay? Which then gives me 4x minus 5y minus 4x plus 9y, okay, equals to 3 plus 1, okay? And you will realize that the 4x can now be cancelled out, which will leave me with -5y plus 9y, which in other words is 4y, okay, equals to 4, so y equals to 1, okay? Same thing, I can choose either equation 1 or 2, but let me choose equation 1, okay? Then 4x minus 5y, which is 1, okay, equals to 3. Then 4x equals to 3 plus 5, okay, which means that 4x equals to 8 and x equals to 2. X equals to 2 and y equals to 1. Okay, to help yourself, it will be good if you can try it yourself 8 and try it yourself 9. And so to summarize everything, for substitution, I would need to isolate one of the unknowns x or y, and then substitute this isolated unknown into the second equation and solve for the other unknown afterward, right? But for elimination, all I need to do is to make sure the values of the coefficient of one of the unknowns x or y are the same before adding or subtracting one equation from the other, okay? And then you can solve for the other unknown. Okay, so right now I need you to try it yourself for 6, 7, 8, and 9. Okay, and complete our full sketch and submit to me. Okay, for those of you who are faster, you can try it 10, 11, 12, and 13 after looking at the work examples and learning how to do those. Okay, yes. So thank you, and I hope to see your workings well done. Okay.